Welcome to 2.4, page 4. If you've been paying attention to me the last couple sections, I've talked about how chapter 2 really, it's about finding zeros. So the whole study of I and imaginaries, the whole use of it for this course is really right here in problems 71 through 76 that we have on here. Maybe I should have some more of these, but we're going to get more practice on this, believe me. So we're just supposed to solve these quadratic equations, and we can try to do that by factoring, or we can use quadratic formula, or in the case of 72 I can go x squared equals negative 32. Therefore x equals plus or minus square root of negative 32. So that is x equals plus or minus, let's see, I'm going to make that 16 times 2 and square root of negative. I'm going to take the I out, is I, and once again, maybe the fourth reminder of this, I make certain that I does not look like it's trying to be underneath. That's an exaggeration, but it's not trying to be underneath the square root. So we get x equals plus or minus square root of 16, 4 times square root of 2 stuck, and the I is outside of that radical. And that's our solution for it. So those zeros would not appear on a graph. There'd be no indication that those are actual zeros if x squared plus 32 is a function and we graphed it. However, they do have a play in some actual real-world fields that was mentioned earlier in here. So factors of 10 that add up to 6 don't have any, so I guess I'm going to go quadratic formula here. So we get x equals opposite of b plus or minus square root b squared 36 minus 4 times 1 times 10. That's minus 4 times 10, or minus 40, all over 2 times 1, all over 2. And I see, oh, this is where these i's are going to come into place. So we get x equals negative 6 plus or minus square root of negative 4 on 2. Little dangerous time here. We can't reduce the 2 and the 6 because the 6 is just a term. So how about negative 6 plus or minus square root of 4 is 2, square root of negative 1 is I on 2. And now I can reduce the whole top and get negative 3 plus or minus I with the whole bottom and get 1 for the denominator. X equals negative 3 plus or minus 1I. Okay. And that's our solve. It doesn't tell us to put any of these things in standard form, so I don't have to put the 0 in front of the plus 4 square root of 2I in number 72. Okay. I'll tell you what, I would go quadratic formula before I'd try to factor this thing anyway, but I suspect there's going to be i's in the answer, which is a dead giveaway that it's not going to factor. So here we go. X equals opposite of b 6 plus or minus square root b squared 36 minus 4 times 9 times 37, all on 2a, all on 18, and I'm going to most definitely go to calculator on that. Let's go. X equals 6 plus or minus square root of 36 minus 4 times 9 times 37. And we get negative 1296. Yikes. All on 18. Wouldn't it be nice if 1296 was a perfect square? I'm rooting for you. And it is. So we get equals 6 plus or minus square root of 1296, 36, square root of the negative 1, I, all on 18, top and bottom reduced by 6 to 1 plus or minus 6, I, all on 3, which is a perfectly fine answer for this section, but I wouldn't be surprised if the solution guide has that as 1/3 plus or minus 6i on 3, 2i. I wouldn't be surprised if the solution's that way. This is good. This is in standard form, maybe slightly better. Just depends on our application. Okay, and finally here, simplify the complex number. We will never leave squares or thirds or fourths in these because we know that I squared is -1. This is 4 times -1. And this is 2 times I squared -1 times another I. So we get -4 minus 2 times -1 plus 2 with that leftover I. So real quickly, here's things that you might see at times, like what is I to the 97th? Well, by time I take I to the 4th, that's I squared times I squared, that's -1 times -1, we get 1. So every time, if I'm cycling up, by the time I get to I to the 8th, I've got 1 times 1, 1. I to the 12th, I've got 1 times 1 times 1, 1. If whatever's up here is divisible by 4, then I to it is 1. Well, this is I to the 96th times I to the 1st, and I to the 96th. 96 is divisible by 4. This is 1 times I. Now let's see how our calculator handles that. Second I raised to the 97th, and I'm claiming it's I, and my calculator claims it's I. Now what about this? I'm not certain, but I'm expecting maybe we're going to see a little rounding here. What if I go I to the 1243rd time? Whoop, clear. I raised to the 1235th, something like that. Now, here it seems like we should either get I or negative I or 1 or -1. Those are really the only options. We'll take a look at this right here. -1.5 times 10 to the -12th. That's -0.00000000000015. It's virtually 0, and that's just rounding error our calculators dealing with. That is just negative I. Likewise, if I had this. This is 1 plus virtually 0 i's. This is just 1. Our calculator will be okay for a while, but it's going to have some trouble later on. Okay, so this is square root of 2i. Take the i's out first to the 6th. Might even want to think of this as 2 to the 1/2 I to the 6th. 2 to the 1/2 to the 6th is 2 to the 1/2 times 6. 2 to the 3rd, I to the 6th, that is 8 times I to the 4th times I to the 2nd. And I to the 4th is 1. So that is 8. I squared is -1, so we just get -8. If the exponent's even, we're going to end up with i's kind of canceling each other. I mean, it may cause a negative to pop up here, but we're not going to have i's in our answer if this exponent's even. If it's odd, there's going to be an I that survives. Okay, so let's see. This is 1 on 2 to the 3rd, 8, I to the 3rd. Now, I to the 3rd is I squared times I, and that's -1 times I. So this is 1 on 8 times -I. That is 1 on -8i. And if I multiply top and bottom by I get I on -8i squared, or I on -8 times -1, or 1/8 times I, or I on 8 if you prefer. Write the result in standard form for each of these. So this is -8 plus 0i, and this would be 0 plus 1/8i, and we've got them. But to be perfectly honest, this is by far up here the most important part of this for us going forward and what we're going to be doing for this course. Okay, and that is it. That concludes what's not too bad of a section for us, I think. Mechanical calculator is going to be very useful in that one. Please ask questions.